This video is on modeling exponentials. The population of grass carp fish is projected to double every 3 months. If the initial population is 400 fish, how many are there expected to be in 15 months? So we are still dealing with both months, but they are doubling every 3 months. So let's write an equation for this. First, we know that the initial value is 400 fish. So we know that y is equal to 400 fish, and they're going to double every 3 months. So we know it's going to multiply by 2. Now, because it's doubling every 3 months, we want to know how many times it'll double in 15 months. So we would take 15 months, and we would divide that by 3 because we have every 3 months it'll double. So 3, then 6, 9, 12, then 15. So this will turn into, instead of it being raised to the third power, it'd be y equals 400 times 2 raised to the fifth power. Because every 3 months happen 5 times inside of 15 months. So it'll double 5 times during this 15 months. So if we want to solve that out, this would give us 12,800 fish in 15 months. Because we have to look at how often it's doubling. Every 3 months, that means that after 3 months, after 6 months, after 9 months, after 12 months, and after 15 months, they'll double. So it doubles 5 times within that 15 months. This next problem says the number of bacteria is expected to triple every 4 hours. So again, tripling, but every 4 hours, not every hour. If there are initially only 6 bacteria, how many bacteria will there be after 12, 20, 52, and 18 hours? So to know it's going to triple, we have to determine how many times it actually triples if it's only tripling every 4 hours. So to do this, we will take the amount of hours we have and divide it by 4, because every 4, we need to know how many times 4 happens within the amount of hours we're given. So we start with our y equals, we know we started with 6 bacteria, we know it's tripling, so it's going to be times 3 raised to, we have 12 hours is how long we want to go for, but it's tripling every 4 hours, so we're going to divide by that 4. So how many times does 4 hours happen in 12? That happens 3 times. So it's going to be times 6 times 3 raised to the third power, because it's 4 hours, so it's 4, 8, 12. That's 3 times it happens. This will give us 162 bacteria, because it's every 4 hours. We'll do the same for 20 hours. How many times does 4 happen in 20? So we know we started with 6 bacteria. It's tripling. We're going for 20 hours, but it only triples every 4 hours. So that gives us y equals 6 times 3 raised to the fifth power, because it will triple 5 times inside that 20 hours. This gives us 1,458 bacteria in the 20 hours. On our next one, we have it in 52 hours. So y equals 6 times 3 raised to the, how many times does 4 hours happen in 52? So 52 divided by 4 is how many times it will triple. That'll be y equals 6 times 3 raised to the 13th power. So it'll actually triple 13 times within the 52 hours. That will give us 9,565,938 bacteria. And the last one of 18 hours. So we know we're starting with 6. We're tripling every 4 hours. So 18 hours divided by 4 y equals 6 times 3 raised to the 4 happens 4.5 times. So it's only tripling 4 and then half of a time. So that's why we have to divide by 4 because it's for every. So the amount of bacteria after that is approximately 842 bacteria. Plugging it into a calculator, we would get approximately 842 bacteria after the 18 hours because it didn't completely triple again because I needed another 2 hours for it to triple again. Which of the following rules would model the number of bacteria y for any given hour x? So this same problem. So we know we're starting with 6. So this has 6, 6, 6, and 6, and we're tripling. So which part of this tells us for any given hour? Well, it's tripling after 4 hours. So if I do it for just 12 here, I would have plugged in the 12. But we saw that for 12 hours, we're only using 3 times. So if I wanted to do 12 hours, I had to do 12 divided by 4. This 12 hours divided by 4 shows us that we have the correct bacteria. This is because it triples every 4 hours. You have to divide the time into 4-hour periods. This lets us know how many times it triples in that period. So it's not tripling 12 times in 12 hours, it's tripling 3 times in the 12 hours because it's every 4 hours. So at 4 hours it'll triple, then the next 4 hours it triples, then the next 4 hours it triples. It does not triple 12 times in 12 hours. It triples 3 times in 12 hours because we're dividing. On this last problem, it says the substance iodine-131 is a radioactive substance that has a half-life of 8 days. If we start with 96 grams of iodine-131, how many grams will be left after 24 days and 52 days? So half-life means that it's going to decay. It'll decay in half after 8 days. So every 8 days, the amount that we have is going to be half. That means that if it's only 5 days, it's not going to be completely in half, but it will be getting closer to the halfway. So 8 days, 16 days, 24 days, and so forth. It will become completely in half after 8 days. So the iodine-131, the 131 is just part of its name, so we're not going to use that in our equation. So if we're starting with 96 grams, that's our initial value. It is going in half every 8 days. So we'll start with the equation. Y equals 96, because that's our original, that's our starting value, times 1/2, because that's how much is going to be left. Half of it. We are taking half of it. But again, it's every 8 days. So after 8 days, it will be in half, and after another 8 days, and after another 8 days. So how many times will the iodine go in half in the period of 24 days? That's when we take our 24 and we divide it by the 8 days. That's where that gives us y equals 96 times 1/2 raised to the 3rd power. That means that it is going in half 3 times during this 24 days. And this gives us 12 grams that are remaining. So after 24 days, we'll have 12 grams. We'll have 12 grams of the iodine 131 left over. So we'll do the same thing with the 52 days. How many times will it go in half if it's going in half every 8 days? So how many times will it cut in half in the period of 52 days? So we'll have y equals, we started with 96 grams. It's cutting in half, but it's 52 days divided by the 8-day period for it to cut in half. This would be y equals 96 times 1/2 raised to the 6.5. So it will not be an exact halfway mark because it's cutting in half exactly 6 times, and then it's cutting in half another half of the time period. So this will give us approximately 1 600 grams of iodine 131 left over. So if we want to write a rule that can be used to model this situation after any given day, we would start with y equals 96 grams times 1/2. Now, again, it's going back to for any given day. So if I said 24 days, it's not raised to the 24th power. It'll be divided by 8. So it's however many days we want, but we have to divide the amount of days by 8 because that's our half-life. However long it takes for it to cut in half, that's what we have to divide by because we need to know how many times it will actually divide by 2 or half in the time period of our days. So if we follow the rule that we did here, we can write an equation for any given day.